Okay, so in today's session, we'll discuss about the tools and techniques we will use in object modeling. Right now we discuss about some data modeling technique in the previous session. This is the continuation of uh, the similar techniques available for object-oriented design. And I hope you have already learned about at least one object-oriented programming language so that you are familiar with some of the ideas such as classes, objects, and then their relationships and so on, so which will be helpful. In today's session, we'll be discussing about the modeling techniques such as use case diagrams, whereas how we can, look at various different users who interact with um, the information systems, and then the features that you are going to have in the system as, what we call use cases. So that's the first thing that we are going to discuss. And then at the same time, we will also look at what we call object diagrams, the relationship among the objects in the object-oriented design in an information system. And then we'll continue our discussion for class diagrams, where we will look at classes and their interactions. Which what we call the static relations. Now, once we finish that part, we'll move on to our last part of the tool set, which is we call sequence diagrams. So in sequence diagrams, we discuss about the dynamic behavior of, or capturing dynamic behavior of information systems. And finally, we are going to have a small group work based on the content. So let's start. Right. As you may have already known, most of the programming languages supports the object-oriented principles, and the common ones are like Java programming, or even the Python supports this paradigm. And one of the things that we will learn in object orientation is, most of the time, if you develop code using object orientation, it will be more modular, more you build what we call the reusable components, and therefore it's easy to maintain as well. So therefore, if you look back what is inside the object-oriented analysis, the whole information system that you are going to develop, we use things called objects. So if you focus on the term objects, that could be anything, like it could be a person, a place, event, or even it could be some transaction. Right. Now, to elaborate a little bit more on the object-oriented, development, we can focus on a simple example. Let's say we have a patient, and then you want to see a doctor, right? Now, I told you like the object could be anything, like a real person. So therefore, patient is an object. So the doctor is also an object. So now the patient wants to make an appointment with the doctor. So that means the appointment is also an object, right? So this is very popular approach. If you look at the system point of view, objects themselves, they interact each other. And we can use, for example, message passing to inform objects to perform various different tasks. So if you perform object-oriented analysis, your end product will be what you get will be the object model. So your information system, you can think of it has a set of objects and object-oriented concepts. Right. So let me start with briefly discussing the objects. As we already discussed, the objects could be person, a place, event, or even a transaction. So you have data and the processes. So that means in a single one, we can talk about this. For example, if you take a customer, you can have a name, you can have an address, you can have an account number, or you can also have a balance. And then customer can perform various different tasks. Sometimes we call methods. For example, customer can place an order, pay a bill, or change their addresses. So as an object, you can see, you can have some data as well as processes within the object. Okay, so here are like some example. If you take the parent object, we have a set of data, which we call attributes. So we will have here name, age, sex, and hair color. Same as the processes we call methods informally. We have two methods, read, bedtime story, and drive in the carpool. Then once you have various instances of these objects, and then you have values for these data. For example, if you take a particular instance, let's say we have 3 instances here. And if you take the first one, we have Mary Smith. We have provide some value. So the name is Mary Smith, and then age is 25. The sex is female, and the hair color is red. So similar to that, you will see another 2 examples. So that means once you have parent object, you can have multiple instances of the parent object. Another example, we have child object, and earlier compared to previous one, you will also have data and processes or attributes and methods. And this time you have a different set of data and different set of processes. So in this particular case, when you take child object, you will find name, age, sex, hair color, and number of siblings. And the methods are different. It's related to this child object. We have pick up toys, eat dinner, play, cooperate, get ready for bed, and so on. So if you look at the instances, the values for these attributes, again, here we have 3 examples, 3 instances. We have James Smith, the age is 3, and the male, and then color is red. It doesn't mention about the number of siblings here. Another example, dog object, we have dog. So we here also we see set of attributes here, methods, name, breed, age, color, sex, and favorite food. And the methods we have tail, eat, fetch, and then sleep. And then again, similar to the previous example, you will see 3 instances, and we have body. The breed is terrier mix, and the age is 12. The color is white, the sex is male, and the favorite food kibis and beans. Right. Okay. So what we have just discussed about the objects as well as the structure. Now we'll go into details. So attributes, what you have seen there is we can think of as characteristics of objects. So sometimes these attributes can inherit or acquire from other objects. For example, if you look at the parent and child, usually we inherit some features from our parents. Similar to that, objects can inherit, some of the attribute from other objects. So, for example, you can have another example, like you can have different states. Now, state means objects' current status. For example, now you are a student in the university, but before that you are hoping to register, right? Then now you are a current student. then after you finish, you go from the sentence, you become alumni, which we call past student. So the student states can be in three states. So future student, current student, and past student. Okay, so this same thing could be applied for bank account, right? So bank account, it could be new, it could be active once you have, funds. Then if you have not interact with your bank account, it could be inactive. And then so if you do need illegally, if you do something that the bank can froze your account, and finally you can close account. So you can see, take a bank account, you can see different states. So state is one of the attributes we use to represent the current status of the object. Right. Another example here, you will see student object and instructor object, and you can see some of these attributes are common, right? Name, addresses, telephone number. So some attributes are common. So which means that sometimes we can, create a generalized object from this, right? But in generally, you can have separate objects like this. And what you notice is you have different attributes and you have different methods. And actually, this is an example for our fitness class, which I'm going to describe in coming session, where, like, let's say as a student, you want to register for let's say a gym or a fitness class. And the first thing is, you have to, should be able to, join the fitness class. You should be able to, withdraw from this fitness class. And then there could be like some methods to change your attributes, like you can identify that you can use, chain addresses, chain telephone numbers, and even the chain status, right? And the instructors are, the helpful in fitness classes. And then if you look at focus on the methods available for the instructors, we have, they can teach fitness class, change availability, and also there are some, methods which will change the instructor's attributes. Right. Now, in the same example, the previous two objects are for persons who interact in the information system. But then if you take the schedule as it is, we can think of it as an object. So if you look at this fitness class schedule as an object, you will see it contains set of attributes like the fitness class number, date, time, type, location, and instructor number, and maximum enrollment for a particular fitness class. And then the methods could be used to interact with the other object as well as make changes to the same object. So adding fitness class, deleting fitness class, change time, date, time, instructor, location, and enrollment. Again, when we register, we can make for each student who register for the fitness class, we can make a registration record. So when you are making a registration record can think it as a separate object, and you will see a set of attributes: student number, fitness class, registration date, fee, and status are recorded. And the set of methods that we will use is to add students, stop students, notify instructor of add, notify instructor of dropping a particular student, and notify all fitness class cancellations, and so on. Right. If you focus on the methods itself, when you talk a particular method, you have a specific set of steps you need to take. So in this graphical representation, you will notice is a method for more fries. The steps is how do you get or how do you accomplish this particular, task, the steps, right? So in this particular case, you will see it basically says you need to heat oil, add fry basket with frozen potato strips, lower basket in the hot oil, check for readiness, and when ready, raise the basket and left drain, pour fries into warming tray and add sauce. Basically, how do you accomplish the more fries method, right? So for each method, you should, identify each of these steps. How do you make? For example, in previous one, we have seen, okay, we have change address. So the steps should describe, how do you change, the address. Another example of adding a student. So you can also see the steps involving in this method, starting from creating a new student instance, and then recording student's number, name, address, telephone number, date of birth, sex, and so on. And then finally, you are saving student data. Right. Now we discuss about the two things about the attributes method. The third one is the messages. So, so in object orientation, basically the objects interact with each other. The way that it interact each other is using messages. So the message can think of it as a command, which tells various different objects what to do within this. So you can see here what happens in this particular case. If you look at students object itself, and let's take one method, let's say add student. So when you say add students, what happens? The message we say that students, basically we interact with this particular method. So this basically tells the same class to adding a student instance. Similar to that, if you take the second one, it's for deleting students. So similar to that, although we have this example only for the same objects, the message could pass into other objects as well. For example, in this particular example, if you look at it, the same message we can use to do various different tasks for other objects. So this concept we call polymorphism, which means like if you say good night, and then various different objects might behave differently. For example, if you look at the parent object according to this graphic, so cause the parent object to read a bedtime story, the dog causes the dog to object to go to sleep, child causes the child object to get ready for bed, right? So similar to that, the messages can be used to interact with other objects. Now, if you take the object itself and when you group it, or when you make it a category, we call a class. So all the objects within the class, you will have common attributes and the methods. So the objects within the class, you can group into subclasses, which we can say more specific categories within the class. So you can notice here, we are, in this particular case, we have we have a class. And you can have the same thing usually in class, and what we have already seen earlier as well. We have three parts. We have name, we have set of attributes, and we have set of methods. So, and then in this particular example, what you notice is using a vehicle class, we can create subclasses. So we have 4 subclasses here. We have vehicle, you can have car, minivan, truck, and school bus. So now, So when you have, you know, a class, and when you're making a subclass based on the class, what happens is you have common attributes. So if you take car, minivan, truck, and school bus, so all these four subclasses, these attributes are methods are common, common for all the subclasses, right? And sometimes we say that it inherits. So the subclasses can inherit their attributes as well as methods. So therefore, these are known as common attributes for the subclasses. But then again, for each subclass, you can have, very specific attributes we call uncommon attributes. But, for example, truck can have a load limit, which is very specific to only to this subclass. Same goes with the school bus as well. Emergency exit location, again, very specific for school bus subclass. Another example, in this one, you will notice that we have class and subclasses. The employee class can be used to create, according to this one, 3 subclasses as managers, office staff, and instructors. So each of these subclasses can inherit their attributes and the methods. So therefore, these are known as common attributes. Right. So manager and office staff, you can notice according to the graphic, it will have the same set of attributes and the methods, whereas the instructor has, set of uncommon attributes. So in this particular case, we have 2 uncommon attributes. We have instructor type and availability. Right. Now, if you put them in classes into group, or we call generalized, then you can create superclasses. So the generalization, you will notice that, for example, you create set of classes. And if you notice that, okay, some of the attributes and methods are common, so best is you put into more generalized class, which we call superclass. So look at this example. We were discussing the employees, and using employees, we are creating instructors. But if you generalize more, you can generalize this as a person. Person is a generalized, version. And this could be common to many other, other classes as well. So for example, if you take name and date of birth could be, common for any person. So therefore, you can see those 2 can put into a what we call superclass person. And whatever the methods are common for everyone could be put it here, like breathe and eat and sleep. We can think they are the common for all the persons. Whereas very specific one, you can retain in the class itself. So you can notice social security number, telephone number, hire date, title, pay rate, and it will be in the employee class. Right, and then the methods. Then the subclass is a more specialized version of this. That means it will inherit, from here. So all the way from here. So this will inherit from this one, and that set will inherit from this one. And then you have some uncommon methods as well. So I hope now you understand this idea. So usually what happens in the development stage, you start with identifying the classes that you need. And then when you need like more specific classes, you might create subclasses. And if you see that there are some common attributes and methods that you want to, generalize, then you can go for superclasses. Right. Now that we have discussed about the basic concepts, and then we need to understand various different types of relationships among the objects and the classes. So relationships allows us to communicate, or it allows us to interact, perform various different, business functions. And the relationships could be used what objects should know about each other, or relations could describe how objects respond to the changes to the other objects, and also the membership in the classes, like we discuss about the super classes and subclasses. Right. And then I already mentioned this idea like inheritance. For example, the child object can take all the attributes and the methods from parents. So therefore, you will notice in this one the idea of inheritance when we have a parent and usually child inherits, right? So if you think about the class and subclass relation, so the class will be parent and the subclass will be the child. So when you have the parent-child relation, you will notice that all the attributes from the employee will be inherited by the child. At the same time, all the methods in the parent object can be inherited in the child. Right. Now, once you have noticed everything like this, or in the information systems, so you represent the persons, the things, and even the transactions as the objects. And once you identify their relations, we can draw something called object diagram, right? So this will give you the overview of the system. So let me give you an example of this. So remember we were discussing about registering a student in a fitness class, and we were discussing actually individual pieces of objects, right? So far. So right now we put everything into a one single place, right? So everything we have discussed, right? So for example, we discuss employee, manager, office staff, and instructor. Let me go back to that one. So we discuss about the employee, and then also the three different, so where was it? So here you can notice. So we discussed this idea about the three different classes. Then again, so that's about superclass and subclass relationship. In an object diagram, this is called is a relationship because manager is an employee, office staff is an employee, and instructor is an employee. So this part actually represent that. Okay, so we have three different types of employees in the information system, right? Then we have student, that is another person. Then remember the students wants to take the fitness class, right? This is what the students wants to register or maybe takes a fitness class. And then so this means that once you takes the fitness class, before taking, you need to make a registration. So to register the students, so there are like few things that you need. First of all, you need the schedule. So you can notice here the manager is the one who determines the fitness class schedule and then list open for fitness classes. So this is must, before you're taking one for the registration. And then you can also get information for office staff administrate the registration code. And instructor is the one who indicate the availability for that, right? And then the registration code should add the particular students and generate roster. So once you do that, the instructor can teach us the fitness class. So as you can see, this object diagram will show you how objects interact each other in a information system perspective. Right. Now that we understand about the objects and their relations, and also like a diagram notation like this, we need to look at more information how to represent things within the information system. Now, when you look at object orientation, when you are going to visualize mainly your requirements, and unified modeling language is widely used method. So information systems development, when you want to visualize and document, UML is commonly used. So if you look at the UML techniques, we are going to discuss different techniques starting from use cases, then use case diagrams, class diagrams, sequence diagram, state diagrams, and activity diagrams. So these are commonly used very diagrammic notations when you're developing an information system in an object-oriented fashion using UML. Okay, let me start with the use case modeling first. Now, if you look at use case, which you can say your dynamic or behavior diagram, we call it a use case diagram in UML. So when you take use cases, you can notice that the oval shape. And sometimes you will notice that this is the book's representation. It's outside, but commonly you will see this is inside as well. So different places we use different notations, so we have to bear that one. So ideally you will use an oval shape to represent use case. And for each use case, usually you will find an actor as well. So you will see a stick figure like this, right? Which represent the actor who interact with this use case. So the use case for this example is make an appointment, and the patient is the one who wants to make the appointment, right? So if you take the use case could be any specific transaction or a scenario, right? Say, what do you mean by scenario? So that means a set of actions, services, or the functions. So making an appointment is a use case, right? So there are several steps should take it, make an appointment, right? So for example, so if you want to make an appointment with the doctor, for example, first of all, you have to see, doctor's availability. And then you have to see whether you have a free, slot to make the appointment. If that is the case, you have to confirm it. So you have a, set of actions you need to perform. So use case we can represent to these steps in an information system, right? So this is what the first thing that we need to understand. So what are the use cases and who are interact with the actors. So usually we have to first identify use case and the actors who involve in this use case, right? Here are like 3 examples. So we have use case, make airline reservation, and the passenger is the actor, and this is the use case. Placing an order is a use case, and then the customer is the actor. Changing pickup address, okay, and then the actor is a bus dispatcher. So you can notice that how use cases as well as the actors are interacting each other. Okay, now let's look at the relationships. Now this is a relationship, right? Although we have that, this is a relationship because, like, for example, here, very simple relationship that passenger wants to make a airline reservation. But then there could be some more, relationships, right? So the relationship, we usually use a line. Sometimes you can notice an arrow. So line which will not indicate, where particular direction, but if you want to make a direction, you can use an arrow. So you can you can label sometimes. So when you want to label, there are two labels usually we use. We can use users or include, or we will say extend. Now, if you use users or include, that means this use case is needed by another one, right? So that means if you use users, it indicates that it's used by another one to perform particular task. And if you say extends, so there are like alternative options, right? When you say extend, there are some alternative options. So as I explained earlier, if you use an arrow, you can use, the direction. We can indicate which use case is being used, that you can indicate with this. For example, now you can notice here, we have the relationships. So remember, we said we have two relationships here. We have users and we have extents. So here we have users example, and you can see this is the use case, and then this is the student, and arrow indicates the relationships. The students is uses this use case diagram at fitness class. So this particular one is uses to produce the fitness class roster, right? That's what the users mean. So for example, here it says students add the fitness class and produce fitness class roster. Uses the result of add fitness class. So you can see what happens here will be used by this use case. Similar to that, instructor is the one is giving you the availability. So we have a change availability as the use case, which will use to update the instructor information, right? So these are like examples. So you can see there are some places we don't put any labeling, but the two types of labeling as we discussed. The first one is users. So whatever the results here will be used by this use case. Right. Next, we can also have a description. The information you gather usually during the requirement modeling. And you need to identify, if you're using use case description, you have to identify actors and their functions, right? For example, takes you as an example. For example, you register for the courses, right? You make payment for semesters. So these are like, in any information system, we need to identify the users and their functions in the information system, right? For example, if we take lecturers, for example, the lecturers can submit results to the information system. So the submit result is a use case, and the actor involved is the lecturer, right? So for each one, you have to have a description, right? For each use case, you have to have what we call a use case description, and that you can form something like a table like this. Now, in this particular example, we are looking at add new student use case, and this is the use case description. So when you want to describe the use case, you can have name for the use case. For example, in this one, the name will be add new students. Then the actor. So who's performing or who's involved in this use case. So as you can see, they are called actors, and it could be either a student or a manager, right? Then there are two cases, right? When you have a use case, that means you are going to perform some function. It could be successful, it could be fail, right? So you can notice the next one is called successful completion. What happens? So and you put all the steps. So successful completion. So this is one, what could happen in this use case, adding a new student. So you check the fitness class schedule for the availability. Manager notify the students, fitness class is open, student pays the fee, and manager registers the student. So everything should happen for the successful completion. Now, there's an alternative. So you check the fitness class and the fitness class is full, which means that it's you are not going to add the new students because you can't basically uh, there's no availability for the fitness class. So that's we call alternative. And then next you can have preconditions. So to execute this use case at new students, first student should request for the fitness class. The post condition is if it is the success, students is enrolled in the fitness class and the fees been already paid, right? And no assumptions. Again, so this is what we call the use case description, right? So basically you need this information to create actors as well as use cases. Right. Okay, we'll now come to our first diagram under the UML, which is we call use case diagrams. Again, remember this is very, very important you to understand because it comes in the group work. So use case diagram, it's we call visual summary of in an information system. So there are a few things that you need to understand. You need to identify the system boundary. Usually we represent as a rectangle, right? So we represent the system boundary as a rectangle shape like this. And then usually we will write down the name of the information system. Then you have to place use cases in the diagram. Usually the representation is oval. That means you can think as a features of the system, right? So for example, in this auto service department information system, we are going to have 3 use cases, or you can think of as features: create work order, update work schedule, and prepare invoice, right? So you have to place use cases on the diagrams. Then you actors, because like each of these features, there are, a person involved in this. Or sometimes it could be some other systems, right? So if you go back, you can notice that. So in this particular one, we will notice that, okay, so the customer is involving in this create work order, and you need, service writer to write this. And in the work schedule, we'll notify the mechanic. Prepare invoice, actually, 2 interactions. Mechanic, you have to first complete the task, and then service writer has to check this. So you will see the all these actors we recognize as a second step. Third one is the relationships. Arrow indicates the flow of messages. So for example, here customer requests the service and the service writer writes this, and then that will update, this, use case, which will notify the schedule. And then you perform this and perform the works. And then this one updates here, checks here to prepare the invoice, right? So in this way, we can identify all the features of the systems as a use case diagram. Another example. So as you can see here, this will create a bus route. And you can notice that the rectangle shape again here with the name of the information system that we will build in the use case diagram. And then again, 3 use cases are identified: create, request the requirement forecast, prepare road plan, and develop staffing plan. And this one actually student initiates it, the requirement. And once that comes in, it comes to dispatcher. And the dispatcher determines the route plan, and you have to notify to develop staffing plan, and the dispatcher creates it, which notifies the driver. Right. So the next, I would like to show you like some example diagrams from other sources. You might notice that there are slight differences in the notations. So I think this is inevitable because different books, different authors will use different notations while drawing the diagram. So we need to understand the slight differences as well. In this particular case, I want to show you what happens in incremental development of information system. What do you mean by incremental? Or like agile, for example. If you take in agile software development, you develop and then you adding or incrementally you develop an information system. So in this particular one, you will notice that the rectangle boxes, the first one is called release one, which indicates that the release one they have developed only for the first four. You can notice here, first four use cases, right? So this is about the class registration. So view class schedule, add class, drop class, and view my classes. So everything actually developed, with the students, and then there's a system for registrar, involving the drop class. And the next release, you will notice that there are 5. That means additionally obtain help use case is developed, which involve student as well as operator. Third one is separated because you have here the two different, actors are involved. So paying fee, we have time, and then the school accounted in the release rate. So that will indicate that how you might develop the use case diagram iteratively. Right. This is another example. Again, I have taken from another book, which indicates more information. What we have noticed is very simple diagrams. And what I have expected you to is actually at least thorough with these. But then again, if you want to include more information, you can go and have labeled relations. Like, remember the two things we have discussed? Users and extents. Users or includes or extents. Remember we discussed? And as well as this one, you have hierarchies as well. For example, you can notice that customer, there could be 2 types of customers. The customer could be a new customer, or customer could be an existing customer, right? And then similar to this one, in this use case also, you have 2 types. So now in these use cases, again, we have, we can have hierarchy here. So it says make an offer, but you can have like make a customer offer or make a new customer. So you can see it's kind of is a relationship that we have discussed early, right? So that means similar the notation, new customer is a customer, existing customer is a customer. Make an custom offer is a make offer, and make a new customer is offer. So you will notice that it's with more information. Right. And then remember the users one. Now includes or users, that means once you make a new custom offer, for that you have to create new customer, right? To make a new custom offer. Similar to that, once you make a custom offer, you have to update customer information. And similar to that, when you make offer, you have to make payment arrangement. So extends, we discuss these ideas that how it includes, right? So this is alternative ones. So when you make an offer, that means you have to make payments arrangements. Extends, you have to update information. Includes, that means users. So you create a customer, new customer, which means you have to make new customer offer. Right. Let me show you another use case. Right. No, that's all. Right. Thanks. So I hope now you should be very familiar with at least these, idea of use case diagram. So before we continue, let's have a small exercise, and this is an individual one. Okay, the next the diagram that we are going to discuss under this is class diagrams. Now, for each use case, we can develop class diagrams, and class diagrams can be used to show how the classes and also their relationships. For example, we can create a class diagram. We can use a use case, and we can identify what are the classes which participate for this particular process. For example, let's say we have borrow book use case. So that means we can identify what are the users in here, and then we can create classes for them. For example, we can create a class for customer or member, and we can create a class for library staff, and then we can also create a class for book, right? And then we can represent their relations. So usually when we represent classes, we put a rectangle shape, and usually it involves with three parts. We have name, and then we have attributes, and we have methods. And then whenever we want to represent any relationships, we have to draw lines. And then once you do that, you can make labels. So for that one, for example, how do you relate this, right? For example, let's say we have a member, and then we have a book. Let's say the relationships is borrow, right? So members borrow books. So book is let's say a class. The member is class. You draw an arrow that indicates that we have a relationship between a member and a book. And then the relation we can indicate by writing or labeling, say that you borrow. Then you can also have extra information like what kind of a relationship you have. We call cardinality, that which we will discuss later on. Like, for example, whether the relation is a one-to-one, one-to-many, and many-to-many, and so on, right? So that's what the last one is. Okay, we'll look at the relationship, the cardinality. Now, in UML notation, slightly different from ER notation or other notations that you might have learned. So let me introduce some example where in UML notation is used. The first one, you can notice that we will have 0 and asterisk, which indicates that 0 or many. So for example, let's say we have an employee, and then we have a payroll deduction. So that means let's say you take a salary, and then sometimes we deduct some amount from your salary. So let's say we have a deductions. So when you say deductions, if you take a particular employee may have no deductions or many deductions. That's what it means. But if you take that particular deduction, that will, attach to only one particular employee, right? Okay, so that's what we have. The next one is you will have 0 or 1, which indicates that employee has spouses, but that employee has no spouse or just one spouse. So that's what it means, 0 and 1. Which you can think it as the min-max notation. So this is exactly what we call the min-max notation. And if you have just one and only one, which means that office manager will be in sales office, and then sales office have one manager, then we can exactly say it's a one-to-one relationship. One indicates that min is 1 and max is 1. Next one, we have one or many, which will say that if you take an order and then item order, so order might contain at least one order or many orders, right? Or many items, you might say, right? So one and many, right? So these are the, kind of relations that we can actually define when you have the relationships. Okay, now we can look at a simple example. So let me explain. Ideally, we take use case, and then for each use case, we draw a class diagram. And we can update, like we take one at a time, and we can have, a class diagram. So in this particular case, you will see class diagrams in a very compact way. We didn't put any attributes or methods here, but this is the class for sales manager, sales rep, sales office, customer, order, and item order. So you can notice here, we have sales manager, managers. This is a relationship. So usually sales managers manages a number of sales representatives. It says 0 or more. And if you take the sales rep side, you have to have a sales manager who's managing you. Similar to that, if you take sales office, it's 1-to-1, which means like sales manager manages one sales office, and sales office managed by one sales manager. And the sales office and the sales reps. So usually sales reps are assigned to one salesman office. Sales office can have 0 or more sales reps. Takes the customers in this scenario. The customers can place orders, 0 or more orders, and the order is placed by one customer. And then order includes one or more items. The items are ordered, placed in 0 more orders. And if you look at the last relationship, if you look at sales rep and the customers, customer will have a sales rep, and then you might have at least 0 more customers assigned for sales rep. Right. So I hope you got the basic understanding of this. But of course, although this is the basic representation, there are like more advanced, relations as well. So let me show you like some example from other sources as well. So the next one I have taken from Navate's book, so about the a company where they have several departments, and then they work on multiple projects. So in this example, you can see the detailed information are given. For example, if you take employee class, you have employee name, the attributes, and the methods. So all these information are given. In department, we can have attributes and also the methods. Now let's look at the relationships. So you can see two relationships between employee and the department. So each employee can work for a department, and department can have, at least one or more, right? Here, although say 4. So this is min-max notation, slightly different from the UML, what you have just discussed. And then you can say it's one or more in this particular case. And then some of the employees manages department, so you can see his managers. But then you record start date, so that's why you put it to a separate box like this. So same relations, but this relation is a manager's relations. That means some of the employees works for managers. So if you look at the notations, if you take each employee may manage 0, 1. If you take department should have at least one employee, right? Then you can also have, let's take one more example here. We have employee and the project. Employees works for projects, works on projects, and the number of hours are recorded in this relation. And you can notice that the employees can work for one or more projects, and the project can have one or more employees. Very interesting one. Let me show you, like you can have a recursive relationship. Recursive relationship means that you have a relationship with the same class. You know that when you take employees, employees are supervised by other employees. So this is the relationship you will have. So since it is indicate the same relation, you can see it, label the sides. So one side is labeled as supervisor, other side labeled as supervisee. So if you take supervisor side, supervisor can have like advising one or more supervisees. And if you take supervisee, you will have 0, 1 supervisor. Right. And then you will have, what else we have? We have aggregation. That means if you take the locations, the department locations, there could be like multiple different locations for the department. So you can notice here, if you look at the department and the location, so the department have at least one or more locations, but locations, it's actually a part of this. Right. Let me explain another where you will have superclass, subclass relations. So in this one, you will notice like couple of classes. We have head office, branch, bank account, transactions, customers, and two subclasses, current account and savings accounts. So let me start here. So this is a relationship, which means that the bank accounts could be a current account or savings account. So which inherit all the attributes and the methods in subclasses as well. And then the relations are marked here. And then all the cardinals are also indicate here as well. Right. Another example, in this particular case, you will also notice the superclass, subclass relationships. We have, for example, person, and we have two types, two subclasses, employee and the customer. And within the employee, then we have shop mechanic and the sales person. And this is actually, we call aggregation. Aggregation might have both the shop mechanic and the salesperson, right? And then here we will have some relations. The customer makes offers. So we will have, if you take customer can make one or more offer, an offer, you will have one customer. And then here you have sales person's writes offers. So salesperson may write 0 more offers, and the offer is written by one salesperson. And then the offer and between the vehicle offer is for one vehicle. And when you take a vehicle, for a vehicle, you can have 0 or more offers. Right. So hope you got an basic understanding about the class diagrams and the usual process also I explained. You start with the use case diagrams, and usually use cases are converted into class diagrams. But this is static. Static means that you don't see exact steps. Remember the times when and what is not considered in previous one. It's just the relationships, but we are not going to look at the detail. So if you need to know the dynamic behavior of these, right, then you have to go for another diagrammic notation called sequence diagrams. So sequence diagrams are known as dynamic modeling of use case diagrams. So in this particular case, we need to use to look at the interaction in the classes during the specific some time period. So there are like some ideas we need to understand. So for example, you need to understand that some classes are represented, and for each class, we have what we call the lifelines. So these dotted lines are known as lifelines. And then there are some messages passed among these classes. Remember, the messages are the ones we use to interact with the classes. That means when you have a message, it will be passed to the second class, and then you get the return, right? And the cross here, which indicate the end of the lifeline. So this behavior, this is called behavioral diagram. So we can understand how exactly, and when in fact, that information we can record with sequence diagrams. Right, so these are the core concepts. The classes we identify using rectangles with the name inside, then lifelines, the dash line, and then it represents the time duration of the object interact with the other objects. The X mark or the cross mark we use to indicate the end of the lifeline. Then you have messages, the direction it runs between the two objects, and the label shows the name of the message. And focus area is, you have vertical shape, the lifeline. So this is the focus we call it. So I told you we use a dash line for the lifeline, and this is the focus. Focus means the time it actually, activates. So this is, we call the focus area, right? So let's look at our previous example where students is trying to register for the fitness class. So you will see 4 classes here: student, manager, fitness class schedule, and registration record. So this starts with the request in the fitness class. So student starts the request, so the focus start, and then you see manager then starts the focus request in the fitness class. So what managers responsibility is, you have to check the fitness class schedule whether the time is available. So that check happens here, fitness class schedule, and then depending on that, it will notify back the students if time is available. Then next, the student has to make the payment. Once the payment received, we need to register student, and we create the register record, and this will indicate that it's end of this lifeline. Right. Okay, some more examples. So this is the basic understanding of this. We can exactly see how classes are interact each other in a sequence diagram. More examples. In a shopping cart, you can notice that 4 classes are here. We have customer represented in the stick figure, but then we have shopping cart, order, and the items. So we started this with the customer creating the shopping cart, and let's say in each shopping cart, the purpose is to find the total that customer needs to make the payment. So here you will notice the arrow which indicates that you are going to get in the total. To get that total for each, you have to get the item price. So you have to get the each item price. So we get the request the get price, and you get the item price. So order contain multiple items, therefore you need to calculate the total. So that will indicate here. And finally, once you calculate the final total, you report it back here. So which indicates in a shopping cart how you actually calculate the total to be paid for the items in the shopping cart. Right. Last one, the state diagram. In the beginning of this session, I described that some cases we will use attribute called state, which indicates the state of an object. For example, as a university student, you have various different states, like your future students, and then your current students, and then your past students, and so on. So similar to that, we can use a diagram to indicate each of these status, and then we say it's a state transition diagram. So in this graphical representation, what you see is a state transition diagram where we will represent state transition of a bank account. So this filled circle indicates the starting point, and this one indicates the end point. So what happens? First of all, you need to open an account to get a new account. So this is the status we indicate. This is new account. When you open an account, it will have a new. Now, then to make it active account, you have to make the deposit. So you see here, we indicate that you make the first deposit and the account will be active, or you can say existing. Right. Now, what might happen from this? Okay, so sometimes depending on some activities, bank or the government might froze some of the accounts. So if you froze the accounts, what happens? Whatever the assets will be frozen, they are bounded. You cannot withdraw money from your account, right? And when you release, the frozen account can become active again. Next one is active accounts can be closed by bank or a customer, which will go to the last state, which we call close account. And this will indicate the. So again, close status can be done in two different ways. One is bank can close or customer can close. Okay, now you understood that how state transition diagrams are drawn. Right. The last one is activity diagrams, which represent the various different activities happen in a particular activity, action, or event. This is to understand what exactly happening in a particular activity. So let me explain this from, and getting an example as withdrawing money from the ATM account. So this circle indicates the starting point, says that customer is the cash. So what happens? This is the first activity or the action performed by the customer. It says customer inserts the ATM card. Then you need the wait until the card is accepted, and then you have to enter the PIN, the next activity. If the PIN is accepted, customer requests cash. So notice here, there are two parts, because if you have enough funds, then ATM will adjust the balance based on the amount you have requested, and it will provide the cash. Let's say customer requests more money than what is available in the account. Then we have another scenario where you don't have enough funds in the account. So therefore, ATM will notify the customer saying that not enough funds are available. Right, that's called activity diagram. Right, so with this one, we finish our discussion. So this is your next group work. As a team, I want you to extend your work for this one as well. For the system that you have assigned, we have to prepare actors and use cases, and then create a use case diagram. And then you select one of the use cases and draw the class diagram. And then you draw the sequence diagram. For example, for library information system, use case could be a borrow book, and then you can draw a class diagram for that particular use case, and then you can exactly draw in a sequence diagram how the borrowing book happens, right? So that's the assessment for this task. Right. With that said, we will finish today's session.